Hello, Rough as Guts Videos returns to your screen with the excitingly named video prog1.c. This is one slide of the lecture notes and what you often describe as a wall of text in the Lab 1. So I'm going to take you through that first program, prog1.c, to show you how it's built up and what the bits are. So to do that, I've got my friend Jeannie over here. I'm going to create a new file. And I'm going to zoom in a little bit so you get nice big fonts, and I'm going to type some stuff into it real fast, magic typing. And I'm going to save that to a file. Notice it's all black. We'll look at the contents later. I'm going to save it as in a folder called week 1, and I'm going to call it prog1.c. prog1.c, and as soon as I've done that, it goes all pretty colours. This means Jeannie now recognises that it's C because I've saved it with a name, and now it can use the syntax highlighter. So if ever your code has not been coloured correctly, you probably forgot to save it with a .c extension. So there's this first program, and there are 3 buttons in Jeannie which I explained earlier in Lab 1, and I'm going to just show you the state of the world with a file browser. There's a file browser, there's a program in it in this folder week 1 called prog1.c. If I were to look at its properties, I would be told that it's a C source code file. No great surprise there. So those 3 buttons, compile, build and execute. Let's click compile. If you followed through Lab 1, you'll know that it executes this command here. GCC with the standard, so GCC is the GNU C compiler, using the C99 standard, showing all errors, all warnings, and treating all warnings as errors, which aborts the possible build of the program. -C means compile only, and the name of the file we're going to do this on is prog1.c. Did you notice over here we've got a new file, prog1.o. If I ask what that's got in it, I discover it's got object code. Now object code is kind of a mystery to you at this stage, but you can think of it as the compiled version of this code that is translated into machine language, but not quite. It's in a state called relocatable. It's just the raw bits of my program here translated. It doesn't have all the other stuff that it needs to turn it into a full executable, such as the printf function there, printf. So normally we don't actually bother using that C compile. We normally go straight to the build command. If I click build, I get a different output here. I get a new thing called prog1 there, that one. If you look at the command it executed, it differs from the last one by saying instead of -C, it has -O prog1. That is, generate the output file prog1. Don't just compile, generate the executable. So this is a fattened version of this one. Instead of just containing the source code for this file here, or the compiled code for this file here, it contains all of that plus everything else it needs to run, most notably the printf function. So if I ask what that's got in it by asking for its properties, I get told that it's an executable program. That means I can execute it, and you might think double-clicking it would therefore be productive, but unfortunately nothing seems to happen. It does happen, but it happens so quickly you can't see it because it just generates some output and it's all over. So what we have to do as well, if we want to really see what's going on, is to create a terminal window or open a nice terminal here and cd into 260 week 1, and if I look in there I get that, and I can run it by typing the command .prog1, as hopefully you noticed in the earlier videos on Don't Bash Bash. Now it runs and says hello world. Great, it's a hello world program. Let's look at it and see if we can understand how it works. So the first line of it, #include_stdio.h, might look to you like a comment, but it most certainly is not. It's called an include. And the C preprocessor is the sort of first step in compiling a C program. It inserts into here, it modifies the source code by inserting a great wad of text. And if we want to look at that wad of text, I can create I'll get my terminal or a different terminal window here. And if I were to, for example, cd into /user include and have a look at the directory listing, I'd find a whole heap of .h stuff, plus a whole heap of other stuff as well, and let's not mind about that. And if I use the nano editor on the file stdio.h, then I find all of this stuff. And I'm certainly not going to go through that. It's a whole heap of C, vast amount of it. By all means, go and explore it, but you're not meant to understand it. It's the header information for all of the standard I/O facilities in the C language. A lot of stuff there. So we're simply going to quit from that. Control X, I'm not going to edit it, not going to modify it, hide that away again. That's what that line does. It's an include. It modifies the source file. It doesn't actually do any compiling, anything clever yet. Then we begin with the declaration of the name of this particular program, which is main. So this is sort of like in Python we'd go def main open close parentheses, right? Here we're a little bit more explicit. First of all, we say explicitly that there are no parameters by writing the word void in there. And secondly, we say what the return type from the function is. This is a function that returns an int. Now, normally this would mean you'd have to have a return statement in it, such as return naught. And that's certainly valid. This is actually a special case for main functions that by default they do the return 0 when they get to the end. A little bit horrible. The return 0 means I return from the program with a nice clean 0. 0 means no errors. If that's non-zero, then it's an error condition of some sort. Let's look at the body of the function. In Python, we would have gone colon, and then we'd have had an indented block. In C, we go open brace, close brace to end the indented block. So the open and closed braces here correspond to the indented block in a language like Python. Now, C is not layout specific. Every line, or every statement, I should say, in C ends with a semicolon. So there's a semicolon to finish that one and that one. This means I can actually write rubbish like this. And I can squeeze it all onto one line, and I can even do the whole thing in one line like a so, and that's still perfectly valid. If I go build it and run it, we get the same output, hello world. So yes, you can do it, but you're not allowed to in this course because Code Runner won't let you. Style guidelines and all that. You have to follow the layout conventions sort of the same as we did in Python. In Python it has to be laid out to work. In C it has to be laid out if Richard's to accept it. Slightly different. The compiler will accept it, I won't. So we've done that bit. What's the next bit? The next bit is a call to the function printf. Hopefully that looks fairly familiar to you. This is a print formatted. In this case, in actual fact, I can use an alternative function called putString, which if I compile or build and run that, it behaves exactly the same. So printf has some more powerful stuff. We'll come back to that later. Normally, I tend to use printf. The string we're printing looks like that. It has to be in double quotes. If I use single quotes, it doesn't work because single quotes you get a format, not a string literal, and no format arguments. Never worry about the detailed, not a string literal. So literal strings in C are double quotes. Single quotes are used for single characters. We'll come back to them later. So there's the first step in my C program. Now let's look at the actual one. The actual one's got rather more stuff in it. Let's walk you through some of the bits. So first of all, inside of this function, I'm going to declare some numbers. Now, this is a really, really important difference between a language like C and a language like Python. If you've done Java, you'll be used to this. If you've just done Python, as probably over half the class have, this is a new idea. I have to declare any variables I'm going to use. Here I'm going to say I'm going to use an integer number, and I'm number 1, and I'm going to use an integer number 2, and I'm going to use an integer total. Now these have a radical, completely new meaning to C from Python. This says reserve some space in memory for some variables. We don't have a dictionary, we don't have objects, we just have lumps of memory. And I just reserved 4 bytes of memory for something I'm going to call number 1, 4 bytes of something I'm going to call number 2, and 4 bytes I'm going to call total. Now, having done all the declarations, I can have some code. Now, comments, start with // or I can have comments starting with /*, as you see over here on this side, your first mindless C program. So comments starting /* must end in // and they can go on for many lines. Comments // are one line only. So this is called declarations, and now I'm going to write some code, and I can say number 1 is equal to 10, semicolon, because I have to terminate it. Number 2 is equal to, I forgot to put the 1 in there. Number 2 is equal to, what have I got there? Let's go with 20 for a start. I'll come back and change to this model in a minute. And then I can say total is equal to number 1 plus number 2. And then I can print a proper formatted print. I can say the sum of the decimal integer first parameter and the decimal integer second parameter is equal to the decimal integer third parameter, and now I have to put the parameters in. So in here I put number 1, number 2 and total. Let's see what happens. Compile and build. It built successfully. Run it. The sum of 10 and 20 equals 30. Right, so just about there, just about explained most of this program. The formatted, the printf thing is a little bit tricky, but it's very much like the format thing in Python, except that it's only used inside printf. It's not a general formatter, it only works inside printf, and I have to have extra parameters to fill in or to plug in the holes. In this case, the decimal integer, %d means decimal, decimal, decimal. Now there's one last piece of code variation I can do here to make it look like prog1 over there, and that is I've added another line, hash define. Now hash define begins with hash, that means it's a preprocessor command, and I can define what are called macros. In this case, the macro is that whenever you see in the body of the text the word second number, you should replace it with the value coming after that definition. So this defines second number to be 20. So here I can go second number. Now, you may think this is the same as saying second number equals 20. It's not. It's totally different. This is a macro. It's pre-processed. I can put anything I like in here, all of that, and it'll be quite happy with the hash define. It'll blow up on trying to compile number 2 equals second number, because then it will be saying number 2 equals all of that twaddle, and it won't make sense. So that is not an assignment statement. It's a symbol replacement, that the symbol second number is to be replaced with all of that stuff. So that's, I think, just about there. I'll do compile. It went a happy little grunt, and then I'll run it. The sum of 10 and 20 equals 30. We use these things in the same ways we taught you to use global constants in Python. So then there was one last change. I can take that line out when I'm using C99, not if I'm using C89. I can take that out and refresh things, and I can compile and build. No change, still works. So that's kind of enough for one video. I've overshot my normal allowed 10 minutes by a bit. Apologies for that, but there's quite a lot in there, isn't there? A first simple program in C. Thanks for watching. Bye.